Structural optimization of fuzzy systems based on determination of linguistic terms number.
Okay, may I start?
Yes, please.
Okay, good afternoon, dear colleagues. Let me introduce the presentation. The structural optimization of fuzzy systems based on determination of linguistic terms number. The structure of presentation is as follows: introduction, the problem statement, the advanced approach for structural optimization itself, the case study at optimization of the electric vehicle, etc., its fuzzy system, and conclusions. So fuzzy logic is a popular and powerful tool for automation of control and decision-making processes, which has a great potential. The intelligent control of fuzzy systems and fuzzy decision-making systems are widely used in industrial automation, transport logistics, medical and technical diagnostics, financial management, stock market forecasting, and other spheres. In particular, fuzzy inference devices also are developed as controllers, observers, adaptive devices, identifiers, tactical control units, and others in automation of complex industrial plants. For example, such plants can be as robotic production lines, power plants, chemical reactors, mobile robots and drones, marine floating structures, unmanned aerial vehicles, and others. The essential feature of fuzzy systems and devices is a large number of adjustable parameters and structure elements that could be adjusted and that significantly affect their performance. Namely, the following are the subject for adjustment: the number of linguistic terms of input and output variables, the types and parameters of membership functions, the antecedents and consequence of the rule base, the number of rule-based fuzzy rules, the input normalizing coefficients, the types of aggregation, activation, and accumulation procedures, and also the defuzzification methods. This allows to implement complex, flexible, and most effective strategies of control and decision-making, but significantly complicates the design procedures of these systems and devices. In recent years, one of the leading research directions in this field is the development and approbation of highly efficient approaches, methods, information technologies for design of fuzzy systems that include certain procedures of structural parametric optimization. Modern fuzzy systems are developed mainly with the help of advanced computer-aided design methods, which contain structural parametric optimization procedures. Also, the cutting-edge studies show that synthesis and optimization of fuzzy systems is carried out not only with the help of classical optimization techniques, but also by means of inspired methods of evolutionary and multi-agent optimization. These methods include genetic and biogeography methods, techniques of differential evolution and artificial immune systems, evolutionary strategies, methods of ant colony optimization, particle swarm optimization, gray wolf optimization, and so on. This study focuses on the solving of challenge of determination of the linguistic terms optimal number, which is one of the most complicated and important. Selection of different variants of linguistic terms number gives the opportunity to implement various strategies of control and decision making at composing fuzzy systems rules, and therefore is determinate the initial sets of antecedents, the number of rules, the possible consequence of fuzzy rules, as well as the number of optimized parameters of the fuzzy system's terms. Moreover, for each new solution found in the process of optimizing the number of linguistic terms, it is necessary to compile a new rule base for determination of fuzzy system performance, which also requires significant computational costs. So the fuzzy system optimal structure is such a variant of structure which ensures, first, the achievement of the optimal performance and accuracy, second, the admissible computational cost for formation of the rule-based and parametric optimization, and third, the acceptable complexity of the hardware and software implementation. In this work, the advanced approach of structural optimization based on determination of linguistic terms optimal number is proposed. The implementation of this approach gives the opportunity to increase the fuzzy system performance and accuracy, to reduce the computational cost spent on the rule-based composing and parameters optimizing, as well as to simplify its further hardware and software implementation. The given approach is based on the concept of sequential search of the best values of the linguistic terms number for fuzzy systems, starting with the first input variable and ending with the last output variable. Moreover, it uses bi-inspired method of end colony optimization and sequential search method for automatic rule-based synthesis for each new obtained variant of the selected vector S that determines the number of linguistic terms. As you can see, it consists of 16 main stages presented in the given block diagram. At the first stage of this method, the vector S is formed depending on the selected at stage 1 n input and m output variables. Also, the complex objective function formed at the stage 6 that consists of two criterions. The first criterion, which evaluates the fuzzy system performance itself, and the second criterion, which takes into account the complexity of the synthesized rule base and accordingly further hardware and software implementation. For example, when designing a fuzzy control system, the first criterion can be presented as the mean integral quadratic error, and the second criterion can be presented as you can see in this slide, which depends on number of rules and number of their consequence that depends on total number of linguistic terms. Also, at the 10th stage, the rule-based synthesis is carried out using the method of end colony optimization or sequential search method. After that, for the synthesized rule base that corresponds to the current vector, the complex objective function is calculated. As the previous comprehensive studies show, the rule-based synthesis method for an effective automatic rule-based synthesis, it is advisable to choose either the sequential search method or the ACO-based method, depending on the complexity of the given rule base. So you can see that if the criterion J2 is less than or equal 600, it is advisable to choose the sequential search methods. In the other case, if this criterion is bigger than 600, the bi-inspired ASO method is more appropriate. The efficiency research of the proposed approach is performed in this work at optimization of the linguistic terms number for a fuzzy automatic control system of the electric car velocity, that is the cruise control system. To simulate the processes of movement of an electric vehicle in this work, a simplified mathematical model is used, which consists of the following basic equations. The developed fuzzy controller has 3 input and 1 output variables. The total number of fuzzy system variables is equal to 4. Here you can see the structure of the vector as it determines the number of linguistic terms for fuzzy controller inputs and outputs that is formed in the following way. Also, here is the initial hypothesis of the vector S that is equal to its minimum possible value, so 3, 3, 3, and 3. Also, the constraints of the vector S are as follows. Only odd linguistic terms number can be used, 3, 5, 7, and 9. And also in this slide, you can see the optimal values that have been chosen that is equal to 20, I'm sorry, and the optimal value of the first criterion that is equal to 10. So the optimization of linguistic terms number using the proposed approach is carried out, and this slide shows the optimization results. In particular, the maximum possible number of iterations was 10 in this case, and as you can see from the table, the objective function optimal value has been found at the 8th iteration, so the search process was stopped. The found in this search process optimal value of the vector S has the following form: 5, 3, 3, and 5 terms. This slide shows the rule-based fragment synthesized in the optimization process for the obtained optimal vector that is generated by means of the sequential search methods. In this case, the rule base consists of 45 rules. The full vector of consequence is as follows. Here you can see the trends and graphs of the electric car velocity control. First line is the cruise control system with designed and optimized fuzzy controller. The second line is the cruise control system with conventional optimally tuned PID controller, and the line 3 is the set value of the velocity that changed 3 times during the transient process in the following way. As can be seen from this graph, the cruise control system with designed and optimized fuzzy controller has higher quality indicators in comparison with the conventionally tuned optimal PID controller. In particular, it has 0 overshoots for all steps and less value of transient time. Also, the value of criterion first is significantly higher for a system with a conventional controller. So the results obtained in this work confirms the high efficiency of the developed advanced approach for structural optimization. And it also confirms the experience of its application for structural optimization of other systems and devices of various types, configurations, and purposes. And the proposed approach allows to increase the fuzzy system performance and accuracy, to reduce the computational cost spent on rule-based composing, and to simplify its further hardware and software implementation. As for the given specific example, the developed and optimized fuzzy controller has enough simple structure and the minimum size of the rule base, which will significantly simplify its further software and hardware implementation. Also, the procedure of the synthesis didn't require much computational cost, that in turn also confirmed the high efficiency of the proposed approach. Thank you very much for your attention.
Thank you. The reporter waits for questions. Any questions to speaker?
I have a question.
Please.
So in the optimization, you use multi-objective optimization, or do you use single objective optimization? Because you have two optimization criteria.
Yeah, it was multi-objective optimization with two criterions, and I used the aggregative approach. So
Okay.
It was the complex objective function that had the first criterion and the weighted second criterion.
Okay, did you understand the shape of the Pareto front? Because sometimes weighted.
No, in this case, I didn't research it. I just set the values of the coefficients just before the research.
Mm-hmm. Okay, so might be interesting to look if it has a good compromise region. But maybe in future research can be done.
Yeah, thank you very much for advice.
Also interesting talk, and it shows that fuzzy controller seem to be much better than the classical PID.
Thanks. Thank you very much.
Thank you.
Thank you very much. Any other questions? No question. Thank you.
Okay, thank you very much for your attention.
We're going to next speaker. Nazar Koval, Anatoly Triguba, Igor Kondesyuk. Any present? Inna Triguba, Oksana Boyerchuk, Mikola Rudenets. No. Okay, next. Marina Yevdokimenko. Is it here? She
Yes,
asked
yes,
me.
I'm here.
Okay, please. You have your word. Share screen, please. Start.
Yes, just a second.
Okay, okay.
Excuse me, one question. Why do you miss evaluation of the informative features of cardiac studies is my report. I'm Halina Padalko.
We passed it.
Yeah.
Sorry, maybe that moment you was absent here.
No, I were here. Okay.
Okay, maybe next time we will see. But it's complicated to check all without order.
Okay.
Please, Dr. Yevdokimenko.
Yes, good afternoon, dear colleagues. My name is Marina Yevdokimenko. I'm from Kharkiv National University of Radioelectronics, and today I want to introduce you my scientific results on the topic investigation of the secure paths set calculation approach based on vulnerability assessment. So today the task of information security of communication network in conditions of increasing number of attacks and intrusion is very relevant. And this is due to the fact that the construction of secure network and the constant development of the infocommunication technology and consequently the growing number of heterogeneous attacks is unfortunately not possible and requires constant implementation of protection mechanism at a level of OSI model. And Bottleneck is the rapid response to emerging intrusions and minimizing the spread of network attacks and the resulting damages. The successful conduct of information security violations of network can be caused by many reasons. For example, from the presence of vulnerabilities in the operating system of network equipment to their incorrect hardware and software configurations. And therefore, special attention should be paid to the network protection methods that are used at the network level, such as traffic analyzer, virtual private networks, firewalls, intrusion prevention system, and so on. And also including the use of secure routing protocols, thanks of which it is possible to improve network security. And as a result of analysis of existing protocol solutions, it is noted that improving the efficiency of secure routing solutions usually requires appropriate improvement of existing and development a new mathematical approach, like models and methods. And to address their shortcoming and corresponding further improvement protocols and secure routing, models formulated the following requirements, as you see on slide number 1. And based on these requirements, an urgent task arises to develop and investigate secure paths set calculation approach based on a routing model. And at the same time, the calculation of secure path is based on the methodology for assessing information risks for the critical vulnerabilities that are present in network nodes. And we use the methodology of risk assessment that you see on figure number 1, and then analyzing. And as a result, based on this, our paper proposed the access vulnerability at the level of network elements. So what about our approach? So the proposed approach based on the routing model, in which the network structure is described by the graph. There's a set of vertices simulated by routers and the set of edges represented in communication links, and the legend of our model, as you see on slide number 2. And then their order of routing in the network is determined by router variables X, each of which characterize the portion of the floor in the link between two nodes of the network. And based on physical content of use route variables, depending on the implemented routing strategy, there are conditions of the form are imposed. We have conditions for implemented multipath routing, as you see, present expression number 1. Also, in the framework of our model, we use conditions for preventing overloading communication link. It is expression number 2. Also, in addition, the floor conservation conditions are introduced for the routing variables, as you see, expression number 3. So the main idea, we take into account the risk assessment of communication link, and then to calculate the information security risk based on exploiting of existing vulnerabilities of the node in the network. We use the following expression according to their standard NIST, as you see, expression number 4. And according to the NIST recommendation, damage of basic vulnerability matrix of network node, the potential damage from the exploiting the vulnerability, we calculate by expression number 5, 6, and 7. Expression 7 characterizes the complexity of exploiting the vulnerability. And then quantify the worst case scenario, the information security risk in case of compromise of the link leaving the node, characterize the following expression of exponential nature, XCC expression number 8. And as criterion optimality, to calculate secure path in the network, we use linear optimality criterion, SCC expression number 9. Their weight W are route metrics that have to take into account the basic security characteristics of link. For our investigation, we use initial data from according to their special base of vulnerability and base of recommendation NIST. And as initial data, we used numerical value of damage indicator for calculating basic vulnerability metrics for network elements, as you see on table number 1, and numerical values for vulnerability assessment system indicators that characterize the complexity of vulnerability utilization, as you see on table number 2. This initial data allow us to calculate their information risk security, and it means a base score and critical vulnerability. After that, for investigation approach for confirmation its sufficiency and adequacy of the obtained result of calculation is carried out. And we use the network consists of 6 nodes, it means routers. In the process of investigation, 1 floor was generated, then the source node of packet was router 1, and the destination node was the router number 6. And the intensity of packet flow varied from 0 to 710 packet per second. And in table 3, each node of the network had a special description of the existing vulnerability according to the database of well-known vulnerabilities of information security CVE. This CVE database is designed to collect, store, and disseminate information about identified vulnerabilities. And each vulnerability is provided this identification number, a description, and a number of publicly available descriptive link. To assess the effectiveness comparative analysis of the proposed approach, we use a special name model 1. This is a flow-based model, which based on the metric of the EIGRP protocol model 2. As shown, in general, the result of use of path of the network for different packet flow intensity, then using model 1 and model 2 are given in table 4. As shown in figure 1 and figure 2, for example, in figure 1, as a result of solving the router problem using the proposed approach, the packet flow of this intensity 450 was transmitted by the router first from router R1, R4, R6, which contained the least vulnerable communication links. And during the congestion of this road, the rest of floor was transmitted in the following vulnerable path. And at the same time, it should be noted that the path which contained the most weight vulnerable communication links was not used at all. So, and during comparison, unlike model 1, then using model 2, the best in terms of bandwidth, number of hops, and in the case of the least vulnerable path was loaded first. So, and as a result, the most vulnerable path, the link of which had the best bandwidth, transmitted the packet flow this high intensity and amounted to 230 compared to the other path. So, as conclusion, an approach to the calculated of security paths based on the routine model take into account information security risks using the basic vulnerability critically metrics is proposed and investigated. And in the process of describing the proposed approach, the apparatus of operational research and set theory was used. Linear programming methods implemented in the MATLAB optimization toolbox were used to solve the secure routine optimization problem. The advantages of our approach is that the calculation of road metrics use special expression which characterize the risk of information security in their network link in accordance with this recommendation of NIST, taking into account different type of damages. And last, the prospect for the development of their obtained solution should be recognized as a synthesis of models and methods of secure routing that can guarantee a given level of network security based on the calculation and use the appropriate routers in the network. Thank you for attention.
Thank you for your report. Have anybody questions to the speaker? No questions. Thank you very much. Then we are going to next report. We turn back to report by Olga Skitsan, Yevhen Minyailo, Ksenia Vasilevich, and Halina Padalko.
Hello. Hello, dear colleagues.
Report evaluation of the informative features of cardiac studies, diagnostic data using Howbeck method. Please.
Hello, do you hear me?
Yes, we are.
Okay, can you see my screen? Right.
Yes, of course.
Hello, dear colleagues. I'm very glad to present you our work, evaluation of the informative features of cardiac studies diagnostic data using the Howbeck method. Okay, so many modern medical institutions have an information system for storing various medical data on the health of patients used by doctors to recognize pathological process. The use of modern information technologies in medicine contribute to the accumulation of huge volumes of medical data stored and processed using medical information system. Mathematical processing of the initial medical data allows you to determine the diagnostic value of indicators or the complexes. In the future, it helps to build an optimal examination plan and significantly reduce the number of studies required for diagnostic and unlimitedly improve the quality of computer diagnostics. There are several reasons for the possibility of transition from a larger number of baseline indicators of the patient's conditions to a significantly smaller number of the most informative features. This is primarily a duplication of information due to the presence of linkings between features, low informativeness of individual features, balanced summation of some features, and the construction of generalized features. Assessment of the informativeness of diagnostic sign is necessary for the objective ranking in order of importance and determination of the order of the consideration in the process of making diagnostics. The aim of the study is to analyze mathematical model of accessing the information content and develop a model of accessing the information content of diagnostic data from cardiac studies. Any biometrical information processing is dedicated to specific purposes such as research, treatment, breeding, etc. Perhaps the most important goal of medical research is the classification of the object or in relation to the patient and disease diagnostics. In particular, the assessment of the informativeness of sign is used in medicine in diagnostic of numerous diseases. Further treatment of the patient depends on the result of the diagnostics. It is possible to make a diagnostics, that is to recognize this or that disease or this absence, provided that the characteristic inherent in object and analyzed. Informative indicators and indicators that make the greatest contribution to the characteristic of the state of the object, like patient. There are numerous methods for determining the information of features. However, unlike other criteria of this statistical significance or differences, the Howbeck measure allows one of the access, not the reliability of difference between division, but the degree of these difference. The method of the analyzing sign by accessing the informative list using the Howbeck informative measure have been widely used in medicine when considering individual factor was influence the diagnostic. In this method, the measure of the difference between the two classes, which is called divergence, is assumed as assessment of the informativeness. To measure the amount of information, Wiener and Shannon independently from each other propose the logarithm measure, which were recognized as a quantitative measure of information. To the class of similar logarithm measure belong, and it is similar studies as a Kullback information measure. G is a discrepancy between statistical distribution 1 and 2. For decreased distribution, this measure is reflected by the formula on the slide. DC is diagnostic coefficient. You can see it. The Kullback method of evaluation of informative measure is based on the calculation of diagnostic coefficients. The diagnostic coefficient is presented in the form of the logarithm of the ability section of feature in main and a control seed. Diagnostic coefficients are most often ambitious or single-digit positive or negative numbers. That is, the diagnostic coefficient with the plus sign of hypothesis A about belonging to the main group with a familiar minus is about a greater likelihood of hypothesis A2 is about belonging to a control group. Obviously, the coefficient with a positive sign carry positive information, bringing the sum of diagnostic coefficient closer to the threshold. Threshold, which is positive for A. Coefficient with a negative sign, on the contrary, removes the amount of the threshold. For hypothesis B, on the contrary, a coefficient with a negative sign brings the sum closer to the threshold, and coefficient with a positive sign see it from threshold, since the threshold is negative value. The considered method in comparison with other method for assessing the information content is the simplest and most accessible for algorithmization. His adaptation machine is not elaboration and does not entail significant compilation cost and resources. The input data in our task is a data set of information on the diagnostic data of patient based on cardiac studies. The age, gender, type of chest pain, cholesterol level, and etc. A complete list of parameters you can see on our slide. For software implementation, the C# programming language was used in the Microsoft Visual Studio environment. To start the software package, you need to download the data present in the CSV file, you know it. In total, for example, data from 303 patients and 13 features was taken. It's like their age, gender, type of chest pain, cholesterol level, blood pressure, and etc. The data is divided into two classes. A is healthy and B is sick. The result of the classification by the Kullback method for accessing the informativeness, the attribute M is like patient age, and it's also shown on the slide. Kullback method gives an estimate of the informativeness of the studies feature in the form of the value. It takes value from 0 to 2. In this case, it's believed that the closer I to 2, the higher the informativeness for the future feature on the contrary, and E from X closer to 0. The lowest the informative value of X. As a result, the information content was calculated from various group of cardiac data. We got the following sign, and the most informative. It's tau, chest pain time, colored vessels, and angina, age, and etc. The Kullback method is used to determine the informativeness of a feature that is involved in the recognition of two classes of object. Also, a comparison of Kullback method with other method for accessing the informativeness of features also are made. As a result of the study, methods for accessing the informativeness of sign for medical data were analyzed. The Kullback method was chosen as a most appropriate method for medical data. On a basis of a Kullback method, a model for assessing the information content built and a software package was implemented. For the experimental study, data from 303 patients and 13 features were used. The information content was calculated for this group of cardiac data. We got the following sign are the most informative, which is tau, chest pain type, color values, angina, and age. The Kullback method is used to determine the informative feature that is involved in the recognition of two classes of object. Also, a comparison of the Kullback method with other methods for accessing the information of future also are made. Thank you for your attention. That's all.
Thank you. Thank you. Maybe somebody has a question.
I have a question.
Please,
Michael?
Dr. Emmerich.
We have similar data sets in Finland in the study, and we also want to understand the health of people, what affects the health. Did you have studies on the how life habits affect the health of patients, or was it a different type of data set?
Not yet, but we are planning to do it in Kharkiv Oblast, actually.
Mm-hmm. This would be interesting to understand. Maybe I will have a look what you are doing there. Mm-hmm.
Okay,
And,
it will be great. Thank you.
mm-hmm.
Thank you.
Thank you.
Oh, another questions here. We have interruption 15 minutes and 13:30. We reconnect again. 15 minutes. Thank you.